Hi guys, good day to you all. So welcome to another class. Today we'll continue our topic on current electricity. Last class we talked about resistance and series, resistance and parallel, the current which is measured in amperes, the resistance which are all measured in ohms. So today we're going to move a step ahead. We're talking about electric energy as well as electric power. Now we all know the common definition of energy. Energy is the capability to do work or the ability to do work. So now when energy is involved, that means work is involved. So as regards to current electricity, we'll be having energy equals to IVT. That is our current times volt times time. That is W equals to IVT. So here now from Ohm's law, we have V equals to IR. That is the volt is equal to the current times resistance. So if you want to substitute your V equals to IR into this equation, we can as well have W equals to IIRT, which is I square RT. So it is either you use this formula for your work done or you use this one for your work done, depending on the parameters given to you in the question. Do you get that? Now for power, electric power equals to what? Work done over time. Work done over time. So here now we've derived our formula for work done, which is IVT. So here we have IVT over the time. So the time can easily cut out time, cut time. So we have P equals to IV. That is P equals to your current times volts. So the formula, the unit for power here is watts, or you use joules per seconds. You can use power equals to what? Watts or joules per seconds. Get me a calculator, please. Now let's look at this question. A heating coil marked 1000 watts. Let us write out the parameter. Remember I said power is measured in watts. So our P here, which is a power, is 1000 watts. Now, which other thing is given to us? Used to heat water for 15 minutes. Now, what is the time? The time here is 15 minutes. So you are going to convert your minutes to seconds by multiplying it by 60. So what do we have here? We have 900 seconds. So what were we told to look for? The energy. Remember that from the question here, you were like, we are looking for work. We're not given current, volts, we're only given time. Can we use this formula? Can we use the second formula? What if we were given power and time? We can easily cross multiply to get our work done. So work done here equals to what? The power times time. The power given to us is 1000 and the time we've converted to seconds is 900. So here the energy is 900,000. Energy is measured in joules. Joules. Is that understood? 9,000 joules. So now let's look at example 2. A tungsten bulb is marked 2000 volts. Let's write out the parameters given to us. What were we given here? The volt is 200, sorry. Now the power is what? 40 watts. And we're told to find the resistance. Remember I told you that the parameter given to you will determine the formula to use. Now here we are given the volts, we are given the power, we are given the resistance. So we are looking for resistance rather. So look at the formula here. Is it W equals to IVT? Is it W equals to I square RT? So which formula do you think you use? And as regards to this one, power equals to work done over time. We were not given work done, we have power, so how do we calculate our time? We can easily make use of the second formula. That is, P equals to IV. Yes, we can use P equals to what? IV. Now, or you can as well say let's make this one the subject of the formula. I equals to P over V. What is our power? 40 watts. What is our volt? 200. So here we have 1 over 5. So 1 equals to I equals to 0.2 amperes. From Ohm's law, V equals to high R. So we can easily substitute V equals to high R to find our R. R equals to V over high. What is our V? Still 200 divided by 0.2. What is 200 divided by 0.2? 200 divided by 0.2. We have 1000 ohms because it's resistance we are looking for. So our R here is 1000 ohms. Do you understand that illustration? Let me adjust the lens of the camera so I can view it well. Good. Now look at this example 3. I'll have to rub up the side for you to understand. Sorry. So, look at the question properly. This is a circuit. In this circuit, we were given different parameters. Now, last class, I told you the arrangement of resistors like this. If your resistance is arranged like this, it is arranged in what? Parallel. That means your R is arranged in parallel. So if you want to calculate the effective or the combined resistance, you now say 1 over R equals to 1 over R1 plus 1 over R2. So what is our R1? 5. What is our R2? 5. So that will be 1 over 5 plus 1 over 5. And that will give us 2 over 5. Our 1 over R equals to 2 over 5. Cross multiply. Therefore, R will now give us 5 over 2 ohms. Or you just say 2.5 ohms. Let me run up the remaining part. So here, I haven't gotten our effective resistance. Which other parameters was given to us? We were given the current I, which is what? 1 amperes. 1 ampere. We were also given the volts, which is equals to what? 10. And remember in the question, calculate the energy developed in 10 minutes. So our time is what? 10 minutes. Convert it to seconds. That will be 600 seconds. Now you can tell me which formula do you want to use to calculate your energy? You can decide to use energy work done equals to IVT because you were given current, you were given volts, and you were given time. You can as well calculate your W equals to I square RT because you've calculated your effective resistance. So whichever formula you want to make use of, you are good to go. Now let's use the simpler one, which is IVT. Work done equals to what? IVT. What is our current? 1. What is our volt? 10. And what is our time? 600. So we have a total of 6,000 joules as our energy. So we have a total of 6,000 joules as our energy developed within 10 minutes in these circuits. Do you understand that now? All right, see you next class. Bye.